Hi, everybody. Thanks for attending my talk today. My name is Chris Sanderson, and I'm an ecologist at Tetra Tech. I've been working in various settings throughout the arid Southwest, including MRG for about 10 years now, and that includes a lot of vegetation and species monitoring, including flycatcher surveys. And I'm just giving some of that background today just because I want to emphasize the applied aspect of these remote sensing studies that are really designed for use by management entities and for ecologists like myself who are interested in GIS and also are love being out in the field. So I'll provide a introduction, there we go, to just the idea and some general concepts related to landscape scale monitoring. A lot of this is dealing with identifying and evaluating, quantifying patterns that may not be apparent during field surveys. A lot of these patterns are things we can't keep pace with. You know, the rate of land use changed or defoliation by Tamarix leaf beetle. So the Tamarix leaf beetle itself has been in the MRG since around 2012. It's known to negatively impact flycatcher breeding and nesting habitat. Of course, it can create an ecological trap for nesting flycatchers. A lot of problems with the Tamarix leaf beetle that I'm sure folks are well aware of. So the use of these tools can be used to track defoliation and quantify it. And the two major vegetation indices that we use to track that change is the normalized difference vegetation index. And this will capture defoliation and mortality via decreasing photosynthetic activity. And that also relates to reduction in biomass and really, as in this case, we're looking at impacts to Tamarix by the Tamarix leaf beetle. So that's our first study that we did for the Army Corps of Engineers. And the second use case I'm going to present today was a really cool project we did for the Sierra Soil and Water Conservation District, the Tiffany Fire down in Socorro County. We used the normalized burn ratio, which is a commonly used metric to evaluate burn impacts. And these can provide really good time-sensitive information to land managers. We use that to inform some of our planning and restoration ecology decisions down there. So these vegetation indices are really just used to construct a temporal trajectory. We can isolate areas for further analysis. And really the idea here is to exploit the reflectance curve of vegetation or soil, whatever you're looking at. So where the rubber really hits the road is in these arid riparian systems. NDVI has been found to correlate with canopy cover of riparian vegetation. And it's also strongly influenced by changes in groundwater conditions and availability. And similarly, the normalized burn ratio has a relationship with the near infrared and on the electromagnetic spectrum there. It's represented in that graphic on the bottom right. So the design of these studies is really important. I have a graphic here that shows the difference between Sentinel pixels versus Landsat. Sentinel is 3 times higher spatial resolution as compared to Landsat. And it also has a really good temporal resolution in terms of when the satellite is revisiting these areas. So you can get a Sentinel scene every 10 days. So that comparison with Landsat is there just because the Sentinel grid is really appropriate for these riparian settings where we can get a finer scale idea of what's happening out there. And Sentinel-2, it's a European Earth observation mission. It's conducted by the European Space Agency, but it's available through the USGS. And that gets into some of the software we use for this. I won't spend too much time here, but there's a constellation of software out there, and there's a lot of different tools to do the same job. I will give a shout out to open source GIS, QGIS in particular, that has some excellent tools for both downloading and doing image analysis for multispectral raster data. So our first use case here is the Tamarix leaf beetle study. And here we found there was a real need to evaluate and understand the ecosystem level changes and consequences of tamarisk as a biocontrol agent on a landscape scale. These successive defoliation or foliation events are difficult to track, as identified in the first couple slides there. So in this case, we looked at 25 river miles and over 8,000 acres of bosque habitat. We used 2016 Hinkenomart vegetation mapping to mask out and exclude other vegetation and just look at tamarisk dominated stands. And we conducted a difference of the NDVI over about 30 different sentinel scenes to construct that temporal trajectory and understand what was happening at these sites. So the raster on the right there with the scale bar is one scene from late July of 2016, just showing what an NDVI raster looks like. That scene is the entire floodplain without the tamarisk mask. In this next scene, we have actually masked the tamarisk, and this is a result of putting together those 30 different scenes into a product that tracks a longer scale, 3 years of sentinel data for this area. So for the tamarisk stands, we saw about a 6% decline in NDVI activity, whereas the non-tamarisk stands saw a 3.3% increase in NDVI. We classed those out in 3 different classes using a zonal analysis just to arrive at a simple decline, no change, or increase in NDVI. And when we did an overlay onto wiffle nest sites, we found that some wiffle nest sites were impacted through this decline in NDVI values. And our assumption there was those nest sites were negatively impacted. Now, some compounding factors for some of these issues is just the nature of the patchiness and refoliation in one growing season. We saw areas that were defoliated where other areas weren't, so there is just a lot of complexity there. I think precipitation does correlate with some of these NDVI return values. And then on the bottom two graphs there, the 2017 and 2018, we were working with some folks from NAU, and the horizontal bars there are defoliation events that simply didn't track with the reach scale analysis we were doing. I think that was mostly due just to the localized impact of the beetle on this system. But again, we did demonstrate that we can identify imperiled wiffle nest sites. So yeah, the next use case here is down in Socorro County again. This is the work we did for the Sierra Soil and Water Conservation District. So the Tiffany Fire, for folks who don't know about it, was a really big fire event. It was lightning caused fire that burned over 9,000 acres, burned a lot of tamarisk. This was a tamarisk infested site. There was a significant loss of cuckoo habitat. And it was a really cool project for us at Tetra Tech because we were able to wield all of our team's skills to perform a suite of analyses from the ecological side, and then getting into the hydraulics and hydrology. So really getting into this eco-hydrological framework to really understand what was happening at this site and understand the challenges at this site. So at the lower right there is the sentinel scene prior to the fire on June 21st, 2017. And then about a month later, in July, that is a post-fire scene. So that just demonstrates the time-sensitive nature of the system. We can get in there every 10 days, assuming there's not a lot of cloud cover. We can get in there and get a good picture of what's happening. So those are the two scenes we selected to perform the difference NBR raster analysis on this. So these are the results. So the frequency chart here shows the distribution of NBR difference in NBR values. So about 30% of the site was unburned, and then about almost 50% experienced a moderate high to high severity burn. And I went out there and checked out the accuracy of these of GIS results, and they were pretty accurate. And this informed our planning for restoration, where we took the results of the burn vegetation, and I was able to identify what areas had burned, whereas what areas did not burn. And this helped us identify both some high value mixed and native habitats that were unburned, and also areas of burned tamarisk that needed to be treated differently versus areas of unburned tamarisk, for example. So this fed into an overall restoration model where we took LiDAR and we established a groundwater model with 4 classes. And these classes that we had were broadly associated with site potential on an eco-hydrological spectrum of mesic to xeric, where the green is a comparatively wetter site to the yellows and oranges you see. We further used, we developed a height above river model, which uses the height of both the low flow channel and the Rio Grande itself, the water elevation in relation to the surrounding landscape. And what we used that for was for more detailed level site planning that you'll see in the next slide here. So here's where all those elements came together. So this site has unburned mixed vegetation we identified that we could build on in a restoration context. So use some of that to develop a nice patch and mosaic in a restoration type scenario. And then we also used the depth to water and height above river model to identify areas that were appropriate for to restore a wetland versus areas that you would want xeric shrubs or xeric grasses. So the whole spectrum is represented at this site. And similarly, we took this other site, it's known as the Condo Site. It's a really cool site. It's previously a wetland and riparian area. It did have flycatcher breeding and nesting in the early 2000s. It's underwent a lot of drying just as a result of persistent drought and some changes in the channel bed elevation of the river. So in this site here, it was more driven by the depth to water and height above river models. But we were able to introduce different restoration concepts, big wetland, big flow through channel, backwater features on this really interesting and compelling site. And the last site here is at the southernmost end of the Tiffany project area, right around River Mile 63. Here we have this gorgeous mosaic that's a result of the application of mostly the depth to water and height above river model, where we have identified these different restoration classes going from wetland all the way into the xeric areas again. And this site has a lot of potential just based on its optimal depth to water values and a lot of existing vegetation and ongoing regeneration dynamics occurring at this site. It's a great site. So what now, you know, these tools can be leveraged in a lot of ways. I've just shown a couple different case studies here. We can identify, using these tools, we can identify opportunities and risks for restoration on a landscape scale. And these also allow a more cohesive kind of approach to restoration projects across a landscape without having to rely on inconsistent data over time. The remote sensing really allows for a consistent approach to understanding these systems. And that's really just repeatability comes to mind. The Army Corps of Engineers. I'd also like to thank the Sierra Soil and Water Conservation District, and also some other authors on the TLB study over at USGS, NAU, and CSU. So that's it, folks. Thank you.